How do we see? Let us learn about an important organ that helps us to see the world around us, that is, eye. It is a very complex organ having various parts like cornea, pupil, eye lens, retina, optic nerve, ciliary muscles, etc.
The eye is a very complex organ that sends a huge amount of information to the brain. It has a very specific design to capture and analyze light. Light rays are reflected from the object and enters our eyes. Light enters our eyeballs through the pupil after passing through the cornea and aqueous humor. The light rays are converged first by the cornea and then by the lens. The light wave continues traveling through the vitreous humor. The light wave gets focused, thus allowing an image formation on the retina. The photoreceptors on the retina sense the light impulses and change them into electrical signals. From the nerve fibers present on the retina, these signals are sent to a nerve bundle that comes out of the back of the eye in the form of optic nerve. The optic nerve sends the signal to the visual center present at the back of the brain. So, light rays reflected from an object enter the eye, get focused, converted into electrochemical signals, delivered to the brain and seen as an image. But the image made on the retina is always upside down and laterally inverted. Well, our eyes send the picture to our brain, and our brain turns the picture into an upright form and tells you what you are looking at. So, we see things the right way up. Actually, we don't see with our eyes, but rather with our brain. We see objects at different distances with the same clarity. What changes take place in our eyes when we look at objects lying at different distances? Actually, the thickness of the lens changes with the action of the ciliary muscles. When the eye is focusing on distant objects, the ciliary muscles get relaxed, and the lens of the eye becomes less convex. It happens the other way around when we see a closer object. The muscles contract to thicken the lens. So, the efforts of ciliary muscles to change the thickness of lens result in focusing the near and far objects clearly on the retina. The eye is able to detect the bright light as well as the dim light. If we are in bright light and try to focus on an object, the pupil will contract to reduce the amount of light that enters the eye. If the same object is kept in a dark room, the pupil will dilate to let in more light to focus on the object. Muscles in the iris contract and dilate the pupil according to the amount of light in the surrounding area. If this is the size of our pupil in normal light, the pupil will contract in bright light, and in dark, our eyes will be dilated to allow more light to enter. That is, the pupil becomes bigger when more light is needed to see an object. So, we can say that human eye can function from very dark to very bright levels of light.
Let us see how much we have learnt about working of our eyes. Multiple choice questions. Select the nerve that sends the signals from the eyes to the brain. The correct answer is option B, optic nerve. Next question. The change in the focal length of an eye lens is caused by the action of the correct answer is option C, ciliary muscles. Next question. The human eye forms the image of an object at its. The correct answer is option C, retina. Next question. When light enters the eye, most of the refraction takes place at. The correct answer is option A, crystalline lens. Next question. The focal length of the eye lens increases when the eye muscles. The correct answer is option C, relax and lens becomes thinner. Next question. A human eye can focus objects at different distances by adjusting the focal length of the eye lens. This is due to. The correct answer is option B, accommodation. Next question. Eye lens is a. The correct answer is option B, transparent double convex lens. Next question. Image formed on the retina of eye is. The correct answer is option A, temporary. Next question. Water liquid in eye lens is known as. The correct answer is option A, aqueous humor. Next question. The nature of the image of an object formed at the retina is. The correct answer is option A, real and inverted.